Hi, welcome to the class. Today we're gonna have the second lecture. As you can see in the class schedule, we are right here. Okay, before I start, let me give you some announcement. First one is the textbook. Okay, I already announced, how to order the book, but for those who did not order the book yet, but you need to purchase the book, just go ahead and try to call them and to order by March 8th, this coming Sunday. Okay, after that, you have to purchase it by yourself, okay? Second is classing. I found some of you did not join the classing offer yet. So for those who did not join the classing, please send me an email or text message to my phone, then I will invite you again. Okay, if you are not in the class, then you may miss a lot of information about course material, okay? And third one is the homework. Some of you may ask about the homework, but I'll just wait and see until most of you will have a textbook because the all of the homework assignment will be drawn from the exercise problem in the textbook. Okay. Okay. That's announcement for today. Okay. Let me just start. Let me start the lecture over here. Okay. Before we start, let me just quickly go over the session we did on Tuesday. We covered the chapter 1 with this topic. The definition of the statistic is why we study statistic and how can we apply the statistic in business and the statistical strategy and some critical thinking, including some kind of pitfall we have to avoid as a statistics analysis. We covered those kind of topics, and today we're going to talk about this topic in chapter 2. The variable and data, the level of measurement. That means, how can we measure the data, or how can we categorize the data depending on the characteristic of inherent data. And we also talk about the sampling concept and method and data source and survey. But I may just skip this part, okay? So main title is data collection. How do we collect the data and how to make an arrangement of the data and how can get the information from the data, and what's the difference between the population and sample, etc. Okay, let me give you a few terminology, the observation, variable, and data set. Okay, here's the definition of the observation. You have to know what that means. Observation is nothing but a single member of a collection of items that we want to study, such as a person, the form, the region, or country, or company, something like that. And variable is a characteristic of the subject or individual, such as an employee's income or an invoice amount. And data set consists of all the values of all of the variables for all of the observation we have chosen to observe. Okay, So data set includes actually observation and variable. Okay, here's the example. Okay, we call this whole table is called data set. And data set consists of observation and variable. So observation is here is 8, 1 through 8 with name. Okay, and each name has attribute of each one's characteristic, representing each one's characteristic. So that can be represented as by using the 5 variables. For example, here is the age, income, position, gender, and education. Okay, age and income is consists of numeric value, numeric data. However, the position and education is just a nominal, kind of nominal data. Okay, position is also kind of nominal data, but gender is a categorical data. Either male or female. So data can be described, in different way. So we call this whole thing, including observation and variable, is called the data set. Okay, now the data set may consist of many variables, as I showed you in previous slide. The question is that that can be explored, and our analytical techniques that can be used will heavily depends on the data type. So let me give you the data type and the and yeah and number of variable and data types will affect what kind of analytic techniques you're going to use. Okay. Okay, data set can also break into 3 types. The univariate, which has 1 variable, and bivariate data set, which has 2 variables, A and B, or and then more than 2 variable, we call that multi-data set, multivariate data set. The, the example I show you in the previous slide, this one is a multivariate data set because we have more than 2 variables. Okay. Okay. So data set can break into 3 type: the univariate, the bivariate, and multivariate. So depends on how many variables you have, 1, 2, or the more than 2. Okay, depends on data set type. The math, the technology, statistic technology you need is different. So when you analyze the univariate data, typically histogram and basic statistic tools is needed. However, if you have the bivariate data, you need to make a scatter plot or correlation, that kind of things. And more than 2 variables if you have, then you may need some kind of regression modeling. So we're going to talk about this kind of technique in the later chapter. Okay, this is the data type and example. Okay, data type in the big picture can break into 2 parts: categorical data or numerical data. Categorical, we call that qualitative data. Numerical data, we call that quantitative data. Quantitative data. Categorical data can also break in 2 parts: the verbal and coded. Verbal and coded. The example of verbal data is gender, the male or female, car, truck, SUV type, something like that. We just, the, the break into in each type or category. Coded data, we just put number there, okay? So vehicle type, we can just code 1, 2, 3. So car is number 1, truck is number 2, SUV is number 3. Gender can also be coded, 0 or 1. The male 0, female is 1, something like that. How about numerical data? This one can break into two parts, discrete data or continuous data. Discrete data and continuous data. Discrete is, we can tell each number, and for example, as an integer value or whole number, like 0, 1, 2, 3, or -1, -2, something like that. But continuous data, you can use the decimal point. For example, 14.275 minutes. Or if you want to express the percentage, the 85.234%, something like that. So we can still break into two parts, discrete and continuous as numerical data. Okay. Okay, now we're going to talk about the two different type of the data called time series data, and bisectional data. Time series data and bisectional data. Okay, what is the time series data? What is time series data? Okay, some data depends on the time. That means it varies. Data value are varied over time. For example, over year, over months, or over day, something like that. The periodicity is the time between observation. So observation will occur in a time-based manner. The January, the February, March, something like that. So periodicity may be annual, quarterly, monthly, weekly, daily, and hourly, even second. It's up to you. For example, the macroeconomic time series data would be include the national income, economic indicators, and the monetary data. That will give you a big picture of the trend, right? However, the microeconomic time series data would be include sales, market share, inventory turnover, etc. So time series data is more interested in the trend or variation over time. Okay, let me give you an example for that data. And the other one is a cross-sectional data. Cross-sectional data. Okay, this type of data are more interested in variation among observation. For example, the account receivable in 20 survey franchise store. They are more interested in the variation among observation over 20 different location of survey franchise. And they're also interested in the relationship between two variables. For example, whether account receivable are related to sales volume in 20 survey franchise. So cross-sectional data is more interested in the relationship or variation in a certain time, at a certain given time. Okay, so for example, this is the the figure of example of time series data and cross-sectional data. Okay, this is time series data. This is what that's right. Number of U.S. bankruptcy over about 30 years, from 1980 to year 2008. Over that time period, what is the variation of number of bankruptcy? Okay, business bankruptcy is the green line, and then customer, the bankruptcy. I mean, the individual customer, the bankruptcy is look like this. So you can see the trend how they vary over time in time series data. However, in cross-sectional data, as we show in this figure, this represents the relationship between the sales volume and account receivable in 20 form. This form can be in a Subway 20, Subway franchise. So at a certain period of the time, at certain the moment, it just to show you relationship between two variables. Of course, we can combine those two type of data. For example, and if we are interested in the relationship between time sales volume and account receivable over many years, then we can just combine two type of data in one graph or something like that. Okay. Okay. Next issue is the level of measurement. How can we recognize? How can we tell the level of measurement in data and the way of coding data? Basically, we break into four type of measurement called nominal data, ordinal data, and interval data, and ratio data. So this is the mechanism how to determine the measurement level. So first question is, nature data is really matter of ordering. If you do matter ordering, the answer, if the answer is no, then you are in nominal data. If your answer is yes, then you have another measurement and bring up another question to be asked. Okay, so first the measurement level is nominal, which is the lowest level. In this data, what you are interested in is just name. What they are interested in is just or the counting, frequency, occurrence. Uh, for example, the sole proprietor or corporation, partnership, you know, just the name, the list of name. Okay, that is the first measurement. They don't. They are not interested in the ordering at all. Okay, just the list of the name is interested. However, if you are interested in the ordering, then you have another question to ask. The scale distance is meaningful. If yes, you have another measurement. If your answer is no, you go to the measurement, second level of measurement, ordinal data. In this case, we are interested in the order, okay? So, for example, the Moody's boundary rating is AAA and CAA, something like that. So AAA is the better than AA, and AA is better than A, and A is better than BAA, something like that. So we are care about the order, so we call that ordering data. And the other one is a distance, okay? So if you are interested in the distance between the data, take a look. This one is a distance between each category has no meaning at all. So the distance between AAA and AA is nothing to do with BAA, between the BAA and BA. Okay, so distance in this case really not the matter. However, take a look at the temperature over here. Temperature. Okay, distance really matter over here. You see that here. Some and distance allowed. The example for this interval data is Likert scale. Likert scale. When you do kind of survey, you have a questionnaire to answer from 1 to 5, sometimes 1 to 7, etc. So in this case, 5 Likert scale, 1 is very poor and 5 is very good, and 3 might be normal, right? In this case, distance is really has some manner. You see, the temperature belongs to in this measurement, because the temperature, the centigrade or Fahrenheit, the distance between the minus 10 degree or minus 20, right? Or minus between minus 20 and minus 30, distance in that case really matters. Okay, another final question is the 0 point is really meaningful. If you say yes, then we have another category called the ratio data. Actually, most of the data we're going to use in this course belongs to this measurement category. In this case, zero value, 0 point will do really matter. Okay. The example I gave you earlier as a temperature, in that case, zero, that doesn't have any meaning. Okay, zero is just to represent any specific point, and particular point from the water to ice or ice to water. Just a reference point. But here in ratio data, zero has a meaning. For example, income. Income zero then means what? Zero. So zero really has a meaning in this category. Okay, let's continue to explain the level of measurement here. The nominal data, so the big characteristic is categories only. That's it, categories only. And for example, eye color, blue, brown, green. That's a kind of nominal data. And second measurement is ordinal. This rank has a meaning, no clear meaning to distance, however. In this case, rarely, never, that kind of thing. The interval data, interval measurement, distance has a meaning. For example, temperature. And finally, the ratio data, the meaningful zero exists. Account payable, the money, the income, sales, volume, that kind of data belongs to this category. Okay, so we talk about the level of measurement, about the data. Okay, let me explain in detail for each category. First one is nominal measurement. Nominal data are qualitative attribute, categorical, or classification data and can be coded numerically. We can make a code. Okay, code number 1 is Apple, code number 2 is Samsung, code number 3 is Dell, code number 4 is Hewlett Packard. That's the name of a company, IT company. So in this category, the only mathematical operations are counting, the frequency I mean, and simple statistic is only required. The second one is the ordinal. Ordinal data code can be ranked. Here we care about ordering. So number 1, frequently. The second is sometimes. Third, rarely. 4, never. So can you see the level are different, which has ordering, right? And furthermore, distance between data code is not meaningful in this data measurement. For example, distance between 1 and 2, or between 2 and 3, or between 3 and 4, doesn't have any meaning. Okay, furthermore, the many useful statistical tasks exist for ordinal data, which are especially useful in social science, marketing, and human resource research. And third measurement is interval. Not only can data be ranked, but it can also have meaningful interval between scale point. Typical example for this measurement is temperature. For example, difference between 60 Fahrenheit and 70 Fahrenheit is exactly same as difference between 20 Fahrenheit and 30 Fahrenheit. Okay. However, 0 point of interval scale is arbitrary. So ratios are not meaningful in this case. For example, 60 Fahrenheit is not twice as warm as 30 Fahrenheit. Ratio does not have any meaning in this case. However, the measurement called the ratio measurement is different. We really care about 0. Actually, ratio data is the highest level of measurement. So the ratio data have all property of nominal, ordinal, and interval data types, and also possess a meaning for 0. Here's the example. So 20 million profit is twice as much as 10 million. Can you see the difference between this type of ratio data and the interval data, the temperature? You see, 60 Fahrenheit is not as warm as twice warm than 30 Fahrenheit. But in this case, in the ratio data, 20 million profit is exactly twice as much as 10 million. So you can see the difference between the interval data and the ratio data. Okay. Okay, Likert scale. We're going to talk about the Likert scale. This is the example actually, the Likert scale. We have five, the Likert scale. The strong agree, somewhat agree, mm, neither agree, or nor disagree. Somewhat disagree or strongly disagree. Another type is how would you rate your internet service provider? Terrible, poor, earthquake, good, excellent. Okay, yeah, this is a kind of table having the question to determine the what kind of measurement the data you have belongs to. The first question is then a meaningful 0 point. If you yes, that's a ratio data. The second question is are interval between scale point meaningful? If you say yes, that's a interval data. And third question is do scale point represent ranking? That means you are interested in the order. Then if you say yes, that's an ordinal data. Okay, final question is are there discrete category? If you say yes, then nominal data. So can you tell the difference between those level of measurement? Yes. This is the key to determine each category of measurement. Okay, and each measurement can recoding. For example, to simplify data or when exact data magnitude is of little interest, the ratio data can be recoded downward into ordinal or nominal measurement, but not conversely. Not conversely. That means you cannot make ordinal data to ratio data, or you cannot make nominal data to ratio data, or something like that. You cannot do that reverse conversely. For example, if you record systolic blood pressure as normal under 130, and the blood pressure between 130 and 140, we just say elevated. And if you have more than 140, we call that high. Then we can say, right, ordinal data, right? Ordinal data by using the ratio data. So we can record the data. You see, in this case, the recorded data ordinal, ranking is preserved, but intervals are unequal and some information is lost. Yeah, we lost some information when we change while recording from the ratio data to nominal data. I mean the ordinal data, from ratio data to ordinal data. Okay, next topic is sampling concept. Sampling concept. Okay, we change the topic now. Okay, what is the difference between population and sample? Okay, population involves all data set of the item one is interested in. Population data might be either finite or infinite. Finite or infinite. For example, all of the passenger on a plane, in a certain plane, all of the passenger, that's a population in a specific situation. However, another example, all of the coke produced in an ongoing bottling process, that's a lot. Of course, that has a finite volume, but practically it is very difficult to count all the coke producing ongoing bottling process. So we just regarded that kind of situation is infinite. Then what is the sample then? Okay, the sample is nothing but just the subset of the population, the part of the population, and it involves looking only at some of the items selected from the population. So now you can see the difference between the population and the sample. Then what is the difference to sample and census? Sample involves looking only at some items selected from the population. Census, that is the examination of all items in a defined population. So when you do, the national census, population census, that means what? Government to try to count all individual who lives in that country. That's just a census kind of concept. But it costs a lot. So it is very difficult to get to try to census survey, right? Because we have some kind of limitation of the mobility, the budget, constraint, and incomplete response, error or bias or something like that. So here's the table, which is showing the both situation where sample may be preferred, some other situation which is census may be preferred. It depends on the situation. Yeah, just you can just refer. For example, if you have an infinite population, then this might be the situation. Sample might be preferred. However, if you have a very, very small population, then you can do census, right? With low cost, you can do that, etc. Just refer that one. Okay, now let me explain the parameter and statistic. What is the parameter? Parameter is a measurement of or characteristic of the population. Some kind of a number describing the population characteristic. However, parameter is usually unknown because we can rarely observe the entire population. It costs a lot. It spent a lot of time. So in general, exact parameter value is not unknown. So that's why we use sample and statistic. Here we go. So statistic is a numerical value computed from a sample. So the statistic can be used as an estimate of parameter because as I said, parameter is usually unknown value. So we use statistic instead. So we use different symbol represent the population parameter and sample statistic. Let's take a look how do they different. Different symbol. We're going to use a different symbol. So in the population, we're going to use mu when you say the average when we say the average of the population, we use mu. But when we use the sample mean, sample average, we use x bar. And the population proportion is denoted as pi, while the sample proportion is just p. So now you can see the difference between the statistics and parameter. And we're going to use different symbol for two different definitions. So here's the graph. Can you see the population versus sample? Okay, for example, this is the population. You know, the size of the population is called the capital N, but the size of the sample we just use this small n, the lowercase n. And parameter is also denoted differently. The population mean is mu, the sample mean is x var, and the proportion of the population is denoted as pi, and the sample proportion is denoted as p. And so x bar is the estimate of mu, and p is the estimate of pi. You see the difference, notation, and different size. So when you say the statistic, that is coming from the sample usually, not the population. Okay, let me talk about the target population. So when you before you try to get the sample, you have to define the target population first, very carefully. Otherwise, you know, sampling might be biased. So target population is for example, the population we are interested in. For example, okay, I'm interested in the gasoline price, U.S. gasoline price. So in that, to get the parameter value of U.S. gasoline price per gallon, for example, then you have to do survey and ask all the gas station in the United States. Maybe, I don't know, maybe 100,000 location, or more than million location, I don't know. But the sample frame is the group from which we take the sample. So we just okay, that's too big. So we're going to sample 115,000 station. So this kind of a frame, should be defined clearly and should not differ from the target population. Okay. Now we're going to talk about the sampling, the method. Sampling method can break into two parts, the random sampling and non-random sampling. So table shown over here is the method of random sampling. We have four different type of random sampling here. Well, okay, let me just explain one by one. Okay, simply, the first one is simple random sample is use random number to select item from the list. We're going to use a random number. It's called a simple random sample. And systematic sample is to select every case item from a list or sequence. And stratified sampling is to select randomly within defined strata by age or occupation or gender. Okay, we'll see later. And cluster sample select a random geographical region that represent the population. Okay, let's take a look in detail one by one. The first one is a simple random sampling. Well, what is that? Okay, we usually denote the population size. I told you capital N, and the sample size is small n. In a simple random sample, every item in the population of n items has the same chance of being chosen in the sample of small n item. So for example, if we draw n chips from a bowl after stirring it thoroughly, and then in a bowl we have n data, like capital N data, and we have the same probability to choose to select. That's a random sampling. For random sampling, we have to one thing have to be considered. Okay, how can we sample? When we sample the without replacement or with replacement, that means what? When we sample one from the bowl, and then before we choose the second sample, can we have to put the first one back into the bowl or not? That's a matter of replacement. Of course, with replacement or without replacement or with replacement, it depends on how you do. The sampling probability might be different. So we need to make a certain rule or criteria. Okay. Instinctively, and most people believe the sampling without replacement is preferred over sampling with replacement because allowing duplicate in our sample seems odd. However, in reality, sampling without replacement can be a problem when our sample size n is close to our population size n. Like I said, without replacement, the remaining items of the population will no longer have the same probability being selected. I think that's the problem. So that's why we set up the criteria. Okay, here we go. So common criteria in statistics world is the 20 times. We regard the finite population is effectively infinite if the sample size is less than 5% of the population. That's what this means. In other words, if you reverse this fraction, if you divide the capital N divided by sample size is supposed to be greater than or equal or greater than or equal to 20. Then in that case, in that situation, we just regard that's infinite cases. So in that case, we don't need to the replacement after sampling because we consider that that is the population is big enough. Okay, big enough, which doesn't make any difference whether you replace it or without replace it. So just remember, the 20 times, okay, 20 or 5%. That's a criterion, the common criterion when you do the sampling. Okay, now what is the systematic sampling? Systematic sampling is, for example, if you sampling 20 out of 78. So if we try to sample of 20, then just roughly you just select every fourth data, you just select every fourth data. So in that case, if you start with the second item, you select the sixth item, 10, 14, 18, 22, 26, 30, 34, 38, etc., etc. So finally, you may get the sample 20 out of 20, out of 78. So in this case, the periodicity selected is 4. Okay, you see how to do the systematic sampling, right? Okay. Now, what is stratified sampling? Stratified sampling. Okay, if you have several different homogeneous subgroup in your population, then from each subgroup you really want to select the same proportion, right? In that case, stratified sampling can be used. So for example, if you have if you want 100 sample consists of 40 and 40% of female and 60% is the male. In that case, you have to select 40 sample from female and the 60 sample from men. Okay, so we call that each homogeneous subgroup, like the male group and female group, we call that strata. And then single subgroup is called stratum. So we have to consider proportion of each subgroup when you select the sample. That means we have to consider the appropriate weight on each subgroup. Okay, that's the key for stratified sampling. Okay, finally, cluster sampling. In this way, we have two types, the one-stage way and two-stage way. Okay, one-stage cluster sampling is you just select the element of each of k randomly chosen subgroup. You just select the k region, okay, k region. For example, if you have more than k region and you just select randomly k region, and from each sub-region you just sample certain amount of size. Just you do that in once, just one step. But when you break into second step, is this way. The first you choose the K sub-region and then choose a random sample of element within each cluster. That means each sub-region. Okay, for example, over here, okay, how many sub-region we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Okay, now we have 12 sub-region, but we need the 3 sub-region. Select the randomly sub-region 3, 1, 2, 3, and each sub-region, from each sub-region we just select 4 data. 3, I'm sorry. Oh yeah, 4. So 4 elements sampled from each of 3 randomly chosen cluster. So actually we select randomly 4 in this region, in this sub-region I mean, and another 4 sample from this sub-region, and another 4 sample from this sub-region. Okay, so this is called the two-stage cluster sampling. So that's a cluster sampler. Okay, now we talk about the non-random sampling. We talk about the four different type of random sampling, but now we also have non-random sampling, which is a quicker way to sample. The first one is judgment sample, and this is just to use expert knowledge to choose typical items. And convenience sample is use a sample that happens to be available in your neighbor. For example, ask your just coworker or colleague, just ask, what do you think, and get some opinion at lunchtime. Just in this case, you can just select, the sample in each way. And focus group, the third method, the in-depth dialogue with a representative panel of individuals. Okay, let's take a look one by one. The first one is judgment sample. Okay, it rely on actually expertise of the sampler. So it can be affected by subconscious bias, right? Subconscious bias. Because absolutely this is not random manner. So it really depends on individual who is sampling. Who is sampling. Okay, convenience samplers take advantage of whatever sample is available at that moment. This is, I think, the quickest way to sample. Just ask your neighbor, ask your colleague, ask your, family or friend. And the focus group, this is kind of what, the brainstorming type, you know. This is just open-ended discussion and idea gathering, okay. So you have to prepare the kind of panel discussion and invite some individual, and you just ask the question you need to by using the specific topic you are interested in. Okay, so we also talk about non-random sampling for three types, but there are many other data collection methods. For example, POS. In a restaurant or gas station, whenever you just slide your credit card, the point of sale, the POS data is accumulated automatically. That's the one way of collecting data. And another type is many companies use a royalty card, right? A royalty card. So this can be matched to purchase of just made. Okay, that's another type of collection method. Or some other one is the email survey. Or you see that Facebook or Google, they have their own survey method, which can track your internet search by using certain, software algorithm. Google has its own analytic solution or service to collect the data. Okay, what else we have? What other issue? Yes, another issue we have to interested in is the sample size. Sample size. Okay, how big of the sample size would be? Well, it depends on the inherent variability of quantity being measured and the desired precision. It depends on, you see, basically the more sample you have, the higher precision you will get. Because you have more sample, that means what? You get close to the population size, so you will get the better result. Another example, the caffeine contents. For example, if you want to collect the caffeine content ratio or something like that. So if you sample the Mountain Dew can at a factory, you may need some small sample because the factory can, the can filled in the factory is almost consistent. Then if you do some individually brewed certain road shop cafe, right? So in that case, you may need less sample, but in this case, you may have more, I mean bigger size of sample. So sample size is really depends on your goal, how precision, how accurate you try to be, or the where are you going to collect the sample. Okay. Yeah, another factor is the cost of sampling, the budget, and time constraint. And it really, those kind of variable also will affect the sample size. If you're busy, you may need a small sample size. If you have plenty of time and money, yeah, you can get bigger size of sample, of course. Yeah. Okay, now let me tell you about the bias between the bias and error. Okay, bias is the really matter of overestimate or underestimate matter. However, the error is this is kind of an accuracy matter, right? Accuracy matter. So when we talk about the bias, we have okay. Here's the source of error or bias. For example, we have two sources of bias here, non-response bias and selection bias, and the rest of the things are coming from error. Response error, the coverage error, measurement error, interview error, sampling error. Error depends on a lot of source. For example, response error is a respondent give false information. They may tell you a lie. Or coverage error is incorrect specification of frame or population. The measurement error is accuracy, unclear survey, instrument wording, interview error, response influenced by interviewer. When you interview some audience, you can drive biasly uh, the answer from the interviewer, from the customer. Sampling error is random and unavoidable. Error might be caused when you are doing sample. Well, yeah, there are a lot of sources, which cause, error or bias. Okay, in detail, non-response bias is what? It occurs when those who respond have a characteristic different from those who do not respond. Yeah, you can just get some idea. If you interview, for example, when you do the interview, for those who like, the iPod and the Samsung Galaxy, then if you just interview the iPod user, the result might be biased. because you do not interview with the Samsung Galaxy user. Yeah, so that's this kind of the bias. Another bias is a selection bias. If you select the self-selected sample, which is not um, which is personally, preferred sample, personally preferred sample, then it is wrong when you select the data or sample or interviewer. So that's the bias called selection bias. Yeah, you can just read that one. Okay, let's move to the some kind of the error. Okay, response error occurs when respondent deliberately give false information to mimic. You see the mimic socially acceptable answer. You know, to avoid the embarrassment or to protect the personal information. That's a response error, of course. The coverage error occurs when some important segment of the target population is systematically missed. And another error might be measurement error. This results when the survey questions do not accurately reveal the construct being assessed. Another one is the interview error, occurs when the interviewer's facial expression, tone of voice, or appearance influence the response. Sampling error. If it is not uncontrollable random error that is inherent in any random sample, so there are a lot of sources of error or bias, so you have to be careful whenever you do sampling. So you have to consider this kind of source of error or bias. Okay, the other one is the data source. Okay, as a statistician, we need data. But fortunately, there are many, many excellent sources of data which are widely open or available. And some sources are given in the following table. Okay, so you can just go ahead and the searching by using this keyword from the internet. You can get a lot of data whenever you need. Yeah, here's the additional source of data from website. For example, if you want to know the economic report of the president, then you can just go ahead and click this one. Okay, the final issue is the survey. Okay, as I told you earlier, let me just quickly go over this one because this is not a main issue as a statistician. In this day, a lot of survey companies, so you can just use or outsource the data from this survey company. But at least, you have to know basic step of a survey research, or sometimes 8 step or 9 step, something like that. The first step is, in general, the state the goal of the research, and the second one is develop the budget, set up the constraint you are available with, time, money, the people. And step 3 is to create a research design. In this case, you have to define the target. What is the target population? Frame, the sample size. What is the appropriate sample size? You have to decide before you do the survey. Choose the survey type and method of administration. And step 5 is design the data collection instrument. Questionnaire. Yeah, you have to make a questionnaire. And step 6, protest the survey instrument and revise as needed. Step 7, administer the survey. That's follow up if needed. And step 8, code the data and analyze it. Yes, I think that's the basic step to the survey. And there are the survey type by mailing. And this is the characteristic. You have to be careful when you do the mailing survey. And another one is telephone survey. Here's the characteristic for that. The other one is interview, and this is the characteristic you have to consider. You have to consider before interviewing. About the website, yes, you can also survey the web by using the web. Or direct observation. Direct observation. You can go to the, uh, the site location you want to observe, and there's a characteristic when you do that. Okay, finally, how can we design questionnaire? Design questionnaire. I just want you to refer that one. Okay. For example, the let represent bypass selection that are not applicable. For example. Questionnaire design, type of question like this. And the other one is a question wording. Yeah, wording is important, to avoid the biased response. The wording is important, I told you. And the other one you have to consider is make sure that you covered all the possibility. All the possibility. How old is your father? How old is your father? Yes. Data quality. Data quality. In this case, the response are coded numerically. Missing value are typically denoted by specific character, something like that. Yes, there's a bunch of the list, to keep the data quality. When you do make a questionnaire, I think this is what you have to consider. Okay, now we can also use the survey software. Survey software. One of the most commonly used application is SurveyMonkey. The other one is Quatrix. Yeah, Quatrix also will be a good tool for surveying. Okay, I think that's all for today. Again, today we talk about the data collection. Data collection. Okay, I hope you just go ahead and review. And we're gonna start with chapter 3. Chapter 3 next week. Okay, this is all for today, and have a nice weekend, and see you next Tuesday. Remember, the official the lecture hour is 3:30. It starts with 3:30 to 5:45. Okay. Okay. See you next Tuesday. Bye bye.